let's evaluate some graphs. So we're going to be using interval notation, and interval notation is using the x values to show the beginning and ending of that interval. And remember, whenever we look at graphs, we always read them like we read an English sentence. We start on the left-hand side and we move to the right. So one of the first things that we're going to look at is whether the function is increasing or decreasing, or is constant, and on what intervals that's happening. So for this particular graph, we're increasing right here because we're starting on the left side of the graph and we're going up. That top part is not included in the increasing or decreasing. We'll talk about that in 1 second. Then we start decreasing till we get to the bottom of that section. And then from there, kind of to the end of our graph, we start increasing again. So when we're identifying that increasing and decreasing intervals, we will use our x values to show where we're starting and where we're ending. One of the other things that you'll notice is that we kind of have this maximum place, which is at the top, going from an increasing to a decreasing. And then we also have this point down here, which is sort of the bottom, where we're going from decreasing to increasing. These are called relative maximums and relative minima. So these are the points in which we're changing direction. And we would write them as a point. And I'll show you how to do that when we do the example. The other thing that we can tell about a function is we can tell whether it's even or odd by looking at the graph. A function that's even is going to be symmetrical across the y-axis. If you have an odd function is symmetric to the origin. So maybe you have something that looks like this. So for even, if you would fold that paper in half right across that y-axis, the left side and right side should be right on top of each other. Whereas when we're symmetric to the origin, it's kind of like if we take this side and sort of turn it, would it be on top of the other part? And then we also have graphs that are neither even nor odd, and that's pretty common. So maybe you have something that looks like that. And there's no symmetry there to the origin or the y-axis. So let's look at an example. So we're going to determine the interval that the graph is increasing or decreasing. So I notice that my graph, I start on the left and it is starting up high and it is coming down until we get to about right here. And then it changes direction and it starts increasing from here up. So we would say, using the x values, that we are decreasing from negative infinity to 3. And we're not going to include 3 because we're not increasing or decreasing there. And then we are increasing starting at 3 and going to infinity. Because this point, that change of direction, is at the bottom of our graph, we have a relative minima value. So we don't have a maxima, so we can write none or NA. And that point at which we have the relative minima is at 3. Okay, notice we're counting by 2, so in the middle would be 3, negative 2. But we write this as min at x is equal to 3 of negative 2. Okay, let's hop over to the back. And we're going to talk about even and odd functions algebraically. So one way you can determine an even or an odd function is we can look at the graph. The other way is we can prove it algebraically. If we have our function and we have, f of x, if we plug in a negative x and we get the same function, that means that we have an even function. So let me show you an example. If we have f of x is equal to x squared plus 2, and we're going to plug in f of negative x. If when I plug in f of negative x, I get this same function, then I have an even function. So I'm plugging in my negative x. I'm going to simplify. We get x squared plus 2. So because these two things are equal, and we got back to the original, the function, so the original function is even. That should also make sense if you think about what this graph looks like. A parabola is that shape of the x squared, and then the plus 2 makes it go up on your graph. So we would go up 1, 2, and then we would have that parabola shaped graph. So looking at it visually, we can definitely see that it is symmetric across that y-axis. Let me show you an example of an odd function. So if I plug in a negative x into my function and the entire function becomes negative, then I have an odd function. Basically, all those values of y are changing from kind of quad 1 down to quad 3. So if we have our original function is x to the third plus x, and let's say that I plug in negative x. If I get back this function but negative, then I know I have an odd function. So I have negative x to the third plus negative x. That's going to give me negative x to the third minus x. I can factor out a negative 1. And we get negative 1 being multiplied by our original function, because here's our original function. So that means that we had our original function, we plugged in that negative x, and we got negative of the original function. So that's how we would get an odd function. So if we would plug in a negative and neither one of those things would happen, then we do not have an even or an odd function. So this is negative 1 times the function. We got the negative of the original. That's it. So just analyzing graphs, looking at their increasing, their decreasing, their minima and maxima, and whether they're even or odd, both visually and also algebraically. All right, let's put all of these pieces together. I lost my page. Starting with, can you remember the difference quotient? You gotta remember that. The difference quotient is f of x plus h minus f of x all over h. And do you remember why we have the difference quotient? It's like the generic rate of change, average rate of change for a curve. For a curved function. Okay. All right, we got a lot of things to answer about this graph. So these are kind of all the things that we have learned. So the first thing is find the domain. So the domain is how wide our graph is. We're going to assume that there's arrows on the end of our graph. And so our graph is starting to go to wide to negative infinity. It is also headed to positive infinity. So our domain goes from negative infinity to positive infinity. The range is the bottom and the top of our graph. So we can see that this side of our graph is headed down, this side is headed up. So our domain is from negative infinity to positive infinity. Okay. The zeros of f is asking when does f of x equal 0? So when are my y values 0? And there's a couple of them in this graph. We can see that right here, our y would be 0. Right here, our y would be 0. And right here, our y would be 0. So our answer here would be when x is negative 4. That was that first point. When x is 2. And also when x is 8. All right, find our y-intercept. Our y-intercept is when the graph crosses the y-axis. So we can see right here, we are crossing, and that is at the point 0, 2. All right, this is what we did last time. When is our graph increasing? So starting from the left and going right, we can see that our graph is increasing here. It stops at that top point, and then it starts again here. So we're going to write the intervals in which our graph is increasing. So we're starting at negative infinity, and we are increasing until we get to 2. Oh, sorry, negative 2. And then we're also increasing, we start over here when we're at 4, and we go to positive infinity. So and what is the interval that we're decreasing? Well, we start here, and then we go to here, decreasing. So at negative 2 to 4, our graph is decreasing. Our graph is not constant anywhere. A constant graph would just be like a horizontal line that we're not increasing or decreasing. So there are none, no intervals. Find f of negative 3. So this is telling us that the x value is equal to negative 3. So we're going to come over to our graph. We're going to find where x value is negative 3, and we're going to go up to our graph. So that's about negative 3. I would say it's about 2. All right, and then this is asking the reverse. What are the x values in which y is equal to 4? So 1, 2, 3, 4. So here's y is equal to 4. There's only one place right here, and that x value is negative 2. So at x is equal to negative 2. These questions are both, they're giving us like half of the point, and we have to find the other value of that point. Find the number at which f has a relative minimum. So we have a relative minimum right here on our graph, and we would say at x is equal to 4 of, and then the y value of negative 2. And then the next question asks about a relative maximum. So the maximum would be the top of our graph, So that would be at the x value of a -2 of the y value, which is 4. So that's kind of like all the things that you can read from a graph. See if you can like pause this, do the next one on your own. I'm going to put some answers in for you, and then we'll hop over to the back. So again, this has an arrow on the end. All right, so our domain for this graph goes from -3 to infinity. The range is from -infinity to 3. Both domain and range always go from the smallest number to the biggest number. Our zeros of f, so when is that y value 0? When x is 4. The y-intercept is happening at the point 0, 3. We are increasing from -3 to -2. We are decreasing from 1 to infinity. And then here we have a constant, -2 to 1. So here on our graph, we're not increasing or decreasing. Our graph is just staying consistent. To find f of 1, we find the x value of 1, and that matches to our y value of 3. And the values where f of x would be equal to 0 are two places. We have both -3, and we also have 3. Oh, I lied. I forgot to change this. Ooh, I gotta remember to change that in your notes. F of x is equal to 1. We'll change it in our notes, but if you're watching this before I changed it in your notes, then now you know. The original answer would have just been at 4, but we kind of already did that when we did C, so it'd be silly to do it a second time. All right, let's hop over to the back. This is all about understanding the notation. So we're finding the intervals in which f of x is less than 0. What does that mean? And then we're also going to find when f of x is greater than 0. Well, in order to understand what the heck you're looking for, you need to remember that f of x means y. So this means when is y less than 0? And when is y greater than or equal to 0? So we're looking at all the y values. Okay, so the blue, everything in this area is when y is, oops, I did the wrong color. Sorry. Y is less than 0 would be less than 0. And y is greater than 0 would be greater than 0. So we're looking for the interval here and here for above 0, and then the interval here for below 0. So our below 0 values go from -2 to +2, where the above 0 values go from -infinity to -2, and then we'll union, I got to write it below, I'm running out of room, from 2 to infinity. Okay. This notation, I'll write it down here. F of x is less than or equal to 0. This is asking when we are below the x-axis. You could think about it like this. And f of x is greater than 0. This is the intervals that we are above the x-axis. So let me show you another example with this one. So we have above the x, oh, wrong tool. So this is where we are above the x-axis, and this is where we are below the x-axis. So we're looking for what is the interval here and here, and then also our interval here and here. And remember, we put arrows on the end. All right, let me do the above axis first. So f of x is greater than or equal to 0. So we're doing the red. So we start at -2. So we're kind of starting here at -2. And we're going along this interval until we reach x is equal to 1. Then we're starting again here at 3. And we're just going to go to infinity. So union 3 to infinity. How about when f of x is less than or equal to 0? So here, we're going from -infinity to -2. And we're going to union, starting here, over from 1 to 3. When we do those intervals, all of those intervals are based upon your domain. Finding the x values for which we are above or below the x-axis. So that's like all the other pieces of the graphing. Putting it all together and then also looking for those intervals.